Now we're going to see how we can use the arc length formula to find the length of this function f, which is equal to x between a and b. We can graph this function here, and since we're learning, so let's say this is between a and b. This is our function. F of x is just x between a and b. So this is a and this is b. And we want to compute the length here. This one, this is L. So this formula here is telling us that L, the length of the graph or the curve, is given by this formula here. We can do it two ways. Okay? We can first use the formula and get the length, or we can use the geometry approach first to find the length of this part of the function. Okay, so let's first find it using algebra or using geometry. So our aim here is to compute this length here. I'm gonna call it h. Okay, and now this segment here, or this part, is b minus a, and the same thing here for this one here is b minus a. Okay, because the function is giving me itself, and therefore I have a triangle here that's rectangle on this side. Therefore I can apply the Pythagorean theorem, and I get h squared is b minus a squared plus b minus a squared. So I get this one, which is b minus a, and this one, which is b minus a, square both of them. And I see that h squared is 2b minus a squared. And if I take the square root, I get h is the square root of the absolute value of b minus a, but since b is bigger than a, I get b minus a. And therefore, the length of this segment between a and b is just the square root of b minus a. This is using geometry or algebra. But now let's see what we can get when we use calculus. In our case, our function here is given by f of x is x, and its derivative is just 1. So f prime of x is 1. Therefore, if we plug the values here, we see that L is the integral between a and b of the square root of 1 plus f prime, which is 1 squared. Therefore, 1 squared is just 1. And this gives me the integral between a and b of the square root of 2 dx. Square root is a constant. I take it outside and I integrate between a and b, which is 1 dx between a and b. And therefore, I have the square root of x between a and b, and evaluating, I get square root of b minus a. So we get the same result using algebra and geometry and using calculus. Okay, remember the formula here. So this is giving me the length of this segment here, or this part of the curve, the length of it. Later we will see that the computation of the length, it's not gonna be as simple as this one, but this tells us that this formula is true. Okay, we can prove it very easily, and later, maybe by the end, we're gonna prove it and we're gonna see what we can get, what we can do with it. But for now, we're just doing simple application so we can remember this formula. This is a new application and it's very simple, and we get the result by algebra and calculus, and both agrees. Okay, thank you very much, and if you see any errors, mistakes, please let me know. Thank you, and I wish you all the best.